Hello everyone, my name is Amy Patel and today my topic is Digital Object Counter, an application of sequential logic in real world automation. So the topic is first of all introduction of Digital Object Counter, components and their detail, use components in Digital Object Counter, block diagram, detailed circuit diagram, working principle, how to Digital Object Counter work, real world application, limitation and challenges, conclusion and future scope. What is the digital object counter? A digital object counter is an electronic device that automatically counts objects as they pass through a sensor. It is a widely used in industrial, commercial, and scientific application for monitoring and automation. Important materials commonly employed in constructing object counter include a 7 segment decoder, 741 operational amplifier, BCD counter, 7 segment display with common anode. So the component required for making a or constructing a digital object counter is list that BCD counter, 7 segment decoder, operational amplifier, register, potential meter, LDR, light dependent register, 7 segment display with common anode and LED. So the next is details of each components. First is a BCD counter 4510 ICs counts or pulses from the sensor and output in BCD format, binary coded decimal format. Act as the main counter, increment by +1 each time an object is detected. 7447 IC 7 segment decoder converts the BCD output from the 4510 IC into a signals for the 7 segment display. Drives the display to show the counted number in 0 to 9. Third is a 741 operational amplifier, amplifies and conditions weak signals from the LDR and converts analog sensor input into a clean digital pulse for the counter. Fourth is LDR, light dependent register, detect the object by sensing changes in light and the sends the detection signals to the 741 operational amplifier for the processing. Fifth is a potential meter. Potential meter adjusts the sensitivity of the LDR circuits and fine tunes when the operational amplifier triggers a count. Sixth is the register. Pull down and pull up register for stable signal. Limits current to the 7 segment display and LED to prevent burnout. 7 segment display common anode is one type of display for the count 0 to 9 connected with the 7447 IC to show the number. 8 is LED, optional indicator for object detection, blinks when counted, when object is counted, provides visual feedback for each count. This is a 4510 IC BCD counter. It is called age trigger synchronous up or down BCD counter. It can count up or down in BCD pattern depending upon the input states. It has a 4 input and 4 output pins for the respective BCD input and output. So we can see input and output and all IC pins diagrams in this 4510 IC. Next is the 7447 IC 7 segment decoder. 7 segment decoder translate a binary coded decimal data into a display form, effectively showing a numerical value in between 0 to 9. We can see that A0 to A3 is a BCD input pins. LT is a LT is a lamp test, represent a display test. RBO is a ripple blanking pin. RBI is the ripple blanking input pin and A2 A to G is the indicate output for the 7 segment display. So this is a 741 operational amplifier. It is called a operational amplifier. An operational amplifier is integrated circuit used primarily for analog computations. It features a very high voltage gain, often around 100 decibel, making it ideal for a signal amplification. In this, we can see that in IC pin diagram, it has 8 pins. 4 and 7 is a power supply, 1 is a offset null, 2 is a inverting input, and 3 is a non-inverting input, and 6 is a on output. In this application 741, in this digital object counter, 741 operational amplifier is used as a comparator. It takes analog input from a sensor such as an LDR, light dependent resistor, amplifies the weak signals, and second is conditions it into a digital pulse suitable for a counter circuit. Next is a LDR, light dependent resistor. Sensor is a device that changes its resistance based on the intensity of light. It is a primarily used to detect the light levels, not for measuring distance. When the light falls on the LDR, its resistance decreases and allowing more current to pass through. Second is a 7 segment display. We talk about a 7 segment display is that type of 7 segment display is a one type of electronic device that displaying result in 0 to 9. 7 segment display is an electronic device which consists of 7 light emitting diodes arranged in some defined pattern. In this type of pattern A, B, C, D, E, F, G, and common cathode or common anode type, which is used to display a number like a decimal type 0 to 9. So the this is a simple block diagram. First is the input stage, second is a processing stage, and third is the output stage. So the system is uses a sensor which is detect the thing object from the real world. We use the LDR light dependent register is used here, which is give analog signal. This signal goes to a processor with a BCD counter 4510 BCD counter. Since the LDR gives analog signals, we convert them to digital before sending to the processor. When the object is detected, the result is shown in the 7 segment LED display. This is a summary of how to work components in the digital object counter. So this is a circuit diagram of digital object counter. This is a LDR1, light dependent register is connected in series with R1 and RV1, variable resistance and resistor, and also called a potentiometer. This form a voltage divider that changes voltage based on light intensity falling on LDR. RV1 is also called a potentiometer or variable resistance to use to adjust the reference voltage level. And RV1 one terminal is connected with the inverting input of the operational amplifier. U1A is called the operational amplifier, plus is called the non-inverting input, and minus is called the inverting input. Non-inverting input receive a voltage from LDR1, and inverting input is receive a voltage from RV1, and output goes high or low based on the comparison triggering further action. This is U2 is called 4510. 4510 BCD counter. We can see that clock pulse is clock pin of U2 is connected with the output of U1 operational amplifier. When the operational amplifier output change due to change in light level, the counter gets triggered and increments the counts. U3 is a 7-segment decoder. Uh, Output pins of U2 Q1 to Q4 of BCD counter is connected with the input pins of 7-segment decoder A to D. We can see in this circuit diagram. U3 decodes the BCD input and drives the 7-segment display accordingly. This is a 7-segment display connected to the output of the U3 connected with the in this circuit diagram. Display a number 0 to 9 depending on the input from the counter. So the working principle first is the input part. The operational amplifier is used as a comparator. It compares the voltage from the LDR connected to the non-inverting terminal with a reference voltage from a potentiometer connected to the inverting terminal, which shown in the circuit. If LDR voltage is a greater reference voltage, then output is high, and the LDR voltage is reference voltage, then output is low. This change in output is used to trigger the next part of the circuit. Second part is a processing part. The main part of processing is a circuit 4510 IC. First pin of this IC is a preset enable. Until it has a 0 input insert, till then the whole IC will be functioning. Otherwise, if it is given 1, then it goes the preset value. If we want to count the input, we need to give 0 to carry input. When signal from input is given to the processor part, preset is enable, clock input and reset must be given to ground. Up and down counter must be given high because we are counting numbers from 0 to 9. Third part is the output part. The output consists of a 7-segment LED. To drive this LED, we need a decoder. Since we are using a common anode 7-segment display, the output of a 4510 IC is fed to 7447 IC, which I told in a circuit explanation. When LDR is distributed by moving object, it sends the object and the count is made on 7-segment display. Hence, we can count the object passing through it. So, this is how digital object counter work. Summary of how digital object counter work. Real world application, industrial, counts of products on conveyor belt for packaging, security, limits people in elevators and stadiums, healthcare, counts pills, blood cells accurately, etc. Like retail, education, consumer. This is a real world application of digital object counter. Next is the limitations and challenges. Limitation of Limitation and challenges of digital object counter. Overlapping object cause under counting errors, poor lighting, reduced detection accuracy, fast moving object leads to missed count, high hardware cost limits scalability, reflective surface confuse sensors, real time processing demands high computational power. Privacy concerns arise with surveillance use. Small and transparent objects are hard to detect. So the conclusion is analog electronic components were investigated and an operational amplifier, LDR, BCD counter, BCD decoder, and a 7-segment display were combined to form a digital counter circuit. Different method and determine the best technique for creating a simple and efficient digital object counter. Uh, and the circuit was designed. Thank you.